Here I can see we are given a question that log x base 2 plus 2 log y base 4 equals to 8, and we are supposed to solve for the value of y. So the first thing that you need to do in this particular question is to check the bases if they are the same, because if the bases are not the same, you cannot be able to proceed until you are able to make the two bases the same. Now, for instance, if you want to make the bases the same, um, if you want a new base, you can be able to use this particular law or rule. But remember the rules of logarithm. The first rule that we identified is that if you have log m base a plus log n base a, that can be written as m times n log of m times n base a. If you have a subtraction and the two logs have the same base, it means you are going to divide the two numbers. And if you have n as a power of m base a, you can be able to take the base that you have, the power behind the log, and you have this. But if you have log m base a and you want to switch the position of m to become a base and a become the number, you can express that as 1 over log a base m. Change of base law. You can be able to change. Sometimes you'll be given questions whereby those questions you don't have the same base. For instance, the question that we have at this particular point. So if you can see here, we are having log x base 2 plus 2 log y base 4. The base 4 is not the same as base 2, so meaning we're going to change that base so that we can be able maybe to make it to base 2, and the law we can use is this one. So if you are changing the base, you are going to say log of the number here divide by the log of this number b, which is the base now in this initial question, and then you introduce the new base that we want. In that case, we are going to introduce base 2. So now let us start this question, because we have gone through the laws and you know exactly what we are supposed to do. So we shall begin by looking at the question and try to rewrite it. So this is actually the question is let me write it. This is log, let me write it, log x base of 2 plus log of y power 2 base of 4 equals to 8. So what we have just done, I've just taken this number that was behind here, this number that we have at this particular point behind the log. I've taken it on top of y. Remember this law that we learned at this particular point. So if you can take the number n behind the log, you can also take it above the power. So if we want to introduce a new base, we are going to say this is log of x base 2 plus log of y squared over log of 4. Then we shall introduce base 2. Base 2 to this is equals to 8. Now once we have this, we can be able to simplify this number that we have here further. That number can be simplified because we can say now this is the same as what? This is going to be the same as log of x base 2 plus log y squared base 2 divided by log of 2 squared base 2, and that is equivalent to 8. Now can take this number that we have behind the log here, and this is going to be log x base 2 plus log y squared base 2 divided by 2 log 2 base 2. But we know anytime you have log 2 base 2, this is actually equivalent to 1 here, and then we shall say this is equal to 8, and finally we shall have log of x base 2 plus log of y squared base 2 divided by 2 equals to 8. We can now write finally this as log x base 2 plus 1 over 2 log of y squared base 2 equals to 8. So if we take this half on top of this, it's going to be log x base 2 plus log y base 2 equals to 8, because now this half, when you take it above y, is going to cancel with that 2, and we end up now remaining with we can combine this using the first law of logarithm. If they are added, we are going to multiply the two numbers, so this is going to be xy base 2 is equals to 8. Now we can be able to express in logarithmic notation. Logarithmic notation, this is going to be equal to xy is equal to 8, or rather this is xy is equal to 2 raised to power 8. And if in case you are supposed to get the final answer here, we are going to say 2 raised to power 8 is actually giving us 256. If you can check it, it's 256, and we're gonna have this as xy equals to 256 as the final answer. Remember, in this question, you are supposed to find the value of this log in terms, you need to find the value of xy, and our xy is actually 256. In this next question, we are given log of a root b minus a half equals to log of a base b. So if we can look at this question keenly, we realize that it's having different bases. So we can now say, we can write this as this is log of root b base a minus a half equals to log of a base b. So we are supposed to solve the equation for b, but we have in terms of a, but we have to ensure that the bases are actually the same. So we are going to write this. Let me just bring this on this side and take the half on the other side. So we shall have log root b base a minus log a base b is equals to a half, is equal to a half there. So what I've just done, I've taken this number on the other side of the equal sign, and I've just taken this on this other side, so that we can be able to have it in that format. So the next thing, we look at the base at this point and the base at this point, they are not the same. So we are going to interchange that. So in order to change this to base a, we can say this is going to be written as log root b base a minus, we shall say this is log a over log b. Remember, we said first you are going to take the log of the number here and the log of the base. So that is what I've just done. So since we want base a, now we're going to introduce base a, and also we shall introduce base a at that point, and we now shall say that this is actually a half. So having this, we can now say this is going to be log root b base a minus log a base a is actually 1. Remember the law we say log of a number and the same base is going to be 1. That's why always we have log of 10 base 10 is 1. If you have log 20 base 20 is going also to be equal to 1. So at that given point, we are going to say this value that we have at the top there is going to be equal to 1. And remember always this law that we have at this particular point. So the whole of this is going to become 1. So we can now say this is 1 over log b base a is equals to a half. Now, at this given point, we can now say we can multiply this, and of course, we can be able to write this as b raised to okay, square root of b is the same as b raised to a half. So we can be able to take a half behind the log and say b base a. Let me just look for more space here so that I don't squeeze this. Okay, so there is this point here. We have log b root b is the same as b raised to a half, and this base a equals to rather minus 1 over log b base a equals to a half. So we can take this number behind the log, and then we shall have a half log b base a minus 1 over log b base a equals to a half log, no, this is a half minus a half, rather equals to a half. So we can decide and multiply all through by this log here so that we can get rid of the fraction. So this is going to be, we multiply log b base a multiply log b base a, and here also multiply log b base a. So you realize at that point this one here and this one will cancel out, but this one is going to end up being a half log b base a, and also we have log b base a, yeah, is minus 1 is equal to a half log b base a. So if we want to work out this, we can say let log b base a be equal to m. So we equate anywhere you have log b base a to be equal to m. So we can be able to form a quadratic equation because this is going to be a half times m, and that is going to translate to a half m squared minus 1 equals to a half m, because on this side we have also b log a, so meaning we are going to have that as m as well there. So meaning that if we multiply all through by 2 so that we get rid of the fraction, this is going to be m squared minus 2 equals to m. So we end up having m squared minus m minus 2 is equals to 0. So we can be able to solve this using factorization, solving this quadratic. We need two numbers whose sum is -1, but their product is -2. So we can say this is going to be m squared minus 2m plus m minus 2 equals to 0. Now the two factors are -2 and 1, so we are going to factor this together, and then we factorize the common term. So factorizing the common term here, we are going to take m out, so it will be m minus 2, and we shall take 1 out, is going to be m minus 2 is equals to 0. So factorizing this, we shall have this as m plus 1 or m minus 2 is equal to 0 at that point. So we can from here find the value of m. M plus 1 will be equal to 0, or m minus 2 is equals to 0. So that means in this case, our first m is going to be equal to negative 1, or m equals to 2. So remember we had said let m be that. So remember we had said that let m be equal to log b base a, and we have factorized this quadratic equation that we formed in terms of m. We have gotten this value and we have gotten this value, so meaning that our m is going to be negative 1 and our m here is going to be positive 2. So we are going to say now, back to the question, we are going to say log b base a equals to negative 1 and log b base a equals to positive 2. So that will mean we can be able to write this equation here in index notation, and in index notation it is going to be b is equals to a raised to negative 1, and this one is going to be b is equals to a raised to power 2, but this one can be written as b is equals to 1 over a, and at this particular point we can say our b is equals to a raised to power 2. So remember in this question we were supposed to find b in terms of a. So this is your final answer at this point, and this is the final answer you are supposed to get on this given area. So we can be able to move to the next question. Okay, so we've been doing this. You can see now the first thing that your eye will notice is that we have the different bases. We have different bases. So if log x base 7, and the next number is 2 log 7 base x, and then we have that 3 there. So definitely what you'll do is working out how can I change the bases so that they are the same. So it's good that we are going to decide and write this to base 7 plus 2 log. So we are going to write this number that we have at this particular point, we convert it so that we have the same base. So we can now say, in order to work out this, we are going to say this is going to be log 7 over log x. We are in the process of changing the base. So since we need base 7, we shall say here is 7 and here is 7. So at that particular point, you'll agree with me that this value that we have here is 3, then the whole of this number is going to run to 1 from this particular part. So we are going to say our equation is going to reduce to log x base 7 plus this is 2 times 1, because already the whole of this number here is going to run to 1. This one is going to run to 1. So 2 times 1 is going to be 2 over log x base 7 is equals to 3. So next step, what are we going to do? We are going to multiply the log that we have at this particular point all through, so that we are going to get rid of the fraction. So we are going to have this as log x base 7 log x base 7 plus 2, because we have already multiplied here, it's going to cancel, then it's going to be 3 log x base 7. It goes without saying that this is going to be written as log x base 7 squared. There is no law that you can multiply logs like this, so you are going to combine them and say it's squared, then plus 2 2, that is 2 equals to 3 log x base 7. And at this particular point, I can see I'm going to have a quadratic equation, and we can see maybe let m equal to log x base 7, so that we can see what this equation can transform to. So what is it going to transform to? It's going to transform to um, um, m squared plus 2 equals to 3m. That's the beautiful equation that we are going to have at that particular point. And this is going to be m squared minus 3m plus 2 is equal to 0. So can we be able to solve this quadratic equation? The answer is yes, because we are going to use either factorization, or we can be able to use quadratic formula. So maybe if we can say using a quadratic formula, using quadratic formula, we are going to say that is going. So applying quadratic formula at this point, we have our a equals to 1, b equals to -2, c equals to 2. So we are going to say our m equals to minus b plus or minus square root of b squared minus 4ac divided by 2a. That is the quadratic formula we are going to use at that particular point. So we are going to have, this is minus 3 minus, so it's going to be positive 3 plus or minus square root of -3 squared minus 4 times a is 1 and c is actually positive 2. So 2 times 1, and this is going to reduce to 3 plus or minus square root of 9 minus 8 divided by 2. So we are going to have this as 3 plus or minus square root of 1 is going to be 1 over 2. So our first value of m is going to be 3 plus 1, which is 4, divided by 2, we are going to get 2. Or 3 minus 1, which is going to be equal to 2 divided by 2, and that is going to be our m equals to 1. So we have two solutions for m, but we had said that let m be log that. So we can say log x base 7 is equals to 2 for the first answer. And if we write it in index notation, that's going to be x is equal to 7 power 2, and that gives us 49. In the first answer is 49. And when m is equal to 1 as such there, we are going to say this is going to be log x base 7 equals to 1. So which will mean that we are going to um, raise this by 1 and say that is index notation. That's going to be x is equal to 7 raised to power 1, and our x is going to be equal to 7. So these are the two answers you are going to get when you are doing this logarithmic notation, solving logarithmic equations. So I would like to take you through the last type of question that we can be able to do. So you can be able to identify and try to work out this question that we have here, so that you can see what you are expected to do. Yeah. So how can you work out a question like this, whereby you are given solve log of 3y squared minus 10 base 4 equals to 2 log y minus 1 plus a half to the base of 4. So this one is straightforward because the two bases are the same. So basically what you do is just applying the first law. So the good thing with this question that we are having at hand here is that it's having the same basis. So we just start working out straight. So this is going to be log 3y squared minus 10 base 4. So I can take this number on this other side. So it will be 2 minus log y minus 1 base 4 is equals to a half. So once we have that, we can now take this to the power, and then we can write this as log 3y squared minus 10 base 4 minus log y minus 1 squared base 4 is equals to a half. So once I have this, I can be able to use the first law, that the second law that we learned here. So when two logarithms of the same base are subtracted, you can divide the numbers. So which means we can write this as a single log, and they say this is 3y squared minus 10 over y minus 1 squared, and then we shall have base 4 is equals to a half. So that we can be able to go ahead and say we can write in logarithmic notation, this is the base raised by a half. So we can say this is 3y squared minus 10 over y minus 1 squared is equals to 4 raised to a half. And 4 raised to a half is the same as square root of 4. So we are going to say this is going to be 3y squared minus 10 over y minus 1 squared is equals to 2. Then we can now multiply this number we have the denominator to both sides. So this is going to be y minus 10, y minus 1 squared, y minus 1 squared. This and this will cancel out, and then we are going to remain with 3y squared minus 10 is equals to 2 into y minus 1 squared. So if we expand and put the like terms together, we are going to say 3y squared minus 10 is equals to 2 into bracket y squared minus 2y plus 1. So if we open the bracket to be 3y squared minus 10 equals to 2y squared, and this will be minus 4y plus 2. So if we bring y on this other side, we shall have this as 3y squared minus 2y squared plus 4y minus 10 minus 2 is equal to 0. So at this given point, we have a quadratic equation. We have a quadratic equation which we can be able to really work on. And this is going to be 3. Okay, if we subtract this, we are going to have y squared plus 4y minus 12 is equal to 0. So you can be able to solve this quadratic equation that we have here so that we can be able to get the value of y. In that case, I just want to solve this quadratic straight away so that we can know what that quadratic is. So this is this is going to be I just want to solve this direct. I give you the answer. Of course, you can be able to solve using quadratic formula. You can use factorization in order to do that. Now I've singled out this part of the equation because we're solving this quadratic equation in order to get the value of y. We can be able to ask ourselves two numbers whose product equals to negative 12, but the two numbers sum equals to 4. Which are the two numbers? If you multiply them, you get negative 12, but if you add them, you get 4. The two numbers are 6 and 2. So in that case, this has to be a negative, so that if you add 6 plus negative 2, you are going to get positive 4. So we are going to say, therefore, in our solution here, that we can write this as y plus 6y minus 2y minus 12 is equals to 0. Because we are solving this using factorization. This is actually y squared. So I'm about to forget this. This is y squared. Then we are going to group this together and this, and then we're going to pick out what is common. So what term is common in this case? We are going to say in the first bracket here, we are going to factor out y. We remain with y plus 6. And here we are going to factor out negative 2 so that we remain with y negative, actually positive 6 equals to 0. So that if you open this bracket, you multiply negative 2 plus times positive 6, you are going to get negative 12 at that particular point. So we are going to factorize, and this is going to be y minus 2 into y plus 6 equals to 0. So at that given point, because we were solving that equation of a logarithm, so we can say this is y minus 2 equals to 0, or y plus 6 equals to 0. So our y is going to be 2, or y equals to negative 6. So there's no way a logarithm can be a negative value, and we are going now to pick our answer for that case to be y as the final answer. This one we are going to ignore negative 6, because if you substitute negative 6 in the equation that we were given, we are going to get a negative, and there's no way we are going to have a negative a logarithm whose answer is a negative value. So in this case, you are supposed to say this is the final answer